right, so last major thing we're going to talk about is volume. So the volume of a solid is the amount of space it occupies, and it's measured in cubic units. So area is in square units, volume is in cubic units. For some solids, which are prisms, if you take a slice or a cross-section of anywhere in that shape where the cross is parallel to the base, it will be the same shape and size. So therefore, to find the volume of any prism, all you need is the area of the cross-section times the height or times the length. And this is given to you in the formula booklet on page 2. All right, so an example of that, Babreca, also known as the Kidney, is a lake in the Rila Mountains in Bulgaria with the shape of a kidney. Its area is 85,000 square meters with the average depth of 28 meters. So we're estimating the volume of water in the lake, estimating because the average depth is 28 meters. So again, to use that prism formula, all we're doing is we're taking the area of a cross section, so the 85,000, multiplying that by the depth, aka the height or the length, all the same thing. And we're getting 2,380,000 cubic meters. Or if you'd rather write it in scientific notation, 2.38 times 10 to the 6th. Still cubic meters. Either way, it doesn't matter which way you write it. It's really just personal preference. All right, so final formulas. Again, all of these are given to you in the formula booklet. Some are on page 2 and some are on page 6. But you don't have to worry about memorizing any of this. Our fifth and final example, we're calculating the volume of each solid. So first up, we have a triangular pyramid where the formula, again, from the formula booklet or from the previous slide, is 1/3 times the base area times the height. So what that tells me is I need to figure out what my base area is. So I'm going to do that first. So my base of my pyramid is a rectangle this time. So length times width gets me 14. So that means for my area, this is step 2, subbing things into my formula. So my base area I just found was 14. My height in the center of the diagram is 7.4. Multiplied all together, I get 34.53, etc. So to 3 significant figures, 34.5 centimeters cubed this time. Part B, we have a cone. So again, the area from the formula booklet or from the previous slide, 1/3 pi r squared times the height. So subbing in what I can see in my diagram, leaving the 1/3 in the pi, but my radius is 3.2 squared. And my height I actually don't have. So they gave us the slant height. Slant height and height are 2 different things. So we'll have to do Pythagorean theorem real quick to figure out what that height is. So leaving my hypotenuse, that's slant height, 11.5 by itself. On the other side, putting my height squared with my radius squared, subtracting 3.2 squared, simplifying, taking the square root, I get that my height is, I'm going to leave it in the radical, just again, not my final answer, so I don't want to round prematurely, as the square root of 121.36. So that's what's going in here. Square root of 121.36. As much as you can, don't round until your final answer. It will throw off your final answer. When I put all of this into my calculator, I get around 118.131. So to 3 significant figures, I get 118 centimeters cubed or cubic centimeters. And so we have a few practice problems ready for you. Again, I encourage you to pause the video, try them on your own, and then check back in a second for the answers. So here are the answers to our first two practice problems. And here is one more practice problem. Again, pause the video, try to figure it out yourself before looking at the answers. All right, so this practice problem has a lot going on. So what I suggest to do first is find the volume of the whole cylinder, then find the volume of the tennis balls. Remember, there's 3 of them, so you're taking the volume of a sphere and multiplying it by 3, and then subtracting those 2. So that'll give you the empty space around the tennis balls inside that container. So I hope that all makes sense for distance, area, and volume in 3 dimensions.